Okay. So last time we spoke about chirality, right? So we said that we can call an object chiral if it is a non-superimposable mirror image, the way my hands are, right? These are what? Non-superimposable mirror images of each other. They look like identical, as if they're identical, but they're not, right? So if you see my thumb is on this side and this thumb is on this side, right? So when I try to superimpose them, but this thumb goes on this side and this thumb goes on this side, right? Even though the fingers, they are superimposable, right? So we say that our hands are chiral, okay? And now your question might be, why are we studying chirality? The reason for that is the entire biochemistry is based on the organic molecules present in our body, like carbohydrates, like enzymes, right? Or like your amino acids. All these show the property of chirality. That is why we are studying chirality here, because chirality is very, very important in knowing the biomolecules present in our body, okay? Now we'll come back to chirality once again in a while, okay? I'm not going to explain enantiomers here. So I'm going to explain you the isomers first, and then we'll talk about what are enantiomers. So we all know isomers, you might have studied in the chemistry as well. We can call two compounds as isomers if they have what? Same chemical formula, right? They're different compounds, but they might have same chemical formula. We call them isomers, right? And if you see here, the table shows here the different forms of the isomers. We are going to talk about stereoisomers and constitutional isomers. The whole chapter is basically based on your enantiomers. So this is our topic. This is our topic. The whole topic is about enantiomers. So that is a topic for the day, okay? But in order to reach to the enantiomers, okay, let's first try to understand what are constitutional isomers. So isomers are of two types, the stereoisomers and the constitutional isomers, okay? We'll first talk about the constitutional isomers. If we talk about constitutional isomers, okay, they can have, I was trying to minimize this. Okay, anyways. Constitutional isomers are those, even though I said that this is not the topic of the day, we are more interested towards the enantiomers, right? The whole chapter is about enantiomers. Okay? So, but in order to understand the difference between the stereoisomers and the constitutional isomers, let's try to know a little bit about the constitutional isomers. So, constitutional isomers are those isomers which have same molecular formula, but the connectivity is different. For example, they have given an example of butane and 2-methyl-propane. Both of them share the same formula, C4H10, but look at this. Isn't it different from this one?
Yes.
This with the straight chain and this with the substituent. Both of them have different IUPAC names. Note this.
Yes.
Both of them will have different physical chemical properties. Look at the boiling point of this and look at the boiling point of the other one.
It's different.
It's totally different. Look at the connectivity, how they're connected. They don't have same connectivity, do they?
No.
Of course not. They don't have same connectivity at all. So such type of isomers will be called as the constitutional isomers. They might have different carbon skeletons, as we saw in propane as well as butane and 2-methyl-propane. Or sometimes, this is just an example I've shown. You don't have to know these examples. Okay? Even these examples are not in your presentations, if you see your presentations. Okay? So sometimes they might have a different functional groups as well. So these two are isomers. But look at the functional group here. We have an alcohol here, and we have a ether over here. Even though what is similar? The molecular formula is similar, but they're two different compounds, two different physical chemical properties. I'll give you a few more examples. Look at this. This is C6H12. Look at the connectivity of atoms. It has 6 different types of isomers. Some of them are cyclic, straight, or some of them are with a double bond. Some of them are with the cyclic. Look at the methyl group is here, right? So it's like the connectivity is different. Why I'm again and again pointing out the difference in connectivity? Because I want to explain you the enantiomers next. There the connectivity is same. Here the connectivity is different. Look at the IUPAC names. All the IUPAC names are different, with different physical chemical properties. So we call such isomers as the constitutional isomers, right? Look at this. This is the same compound, and here I have what? 2, 4. Here the methyl group is on the position number 2 and 4. Here the methyl group is on the position number 2 and 3, and they become the constitutional isomers. The connectivity is totally different. Yes, boys on this side. Right? Again, the same example. Different isomers with different connectivities. Right? So all these would be called as the constitutional isomers. So we learned that in constitutional isomers, they have what? Same molecular formula, different connectivity, different physical properties, different chemical properties, right?
Yes.
But that is not the case with the stereoisomers. Two things can behave as a stereoisomer, so two compounds can behave as a stereoisomers if they have the same molecular formula, same IUPAC name, but what about connectivity? Will it be same or different in stereoisomers?
That's what we discussed. Because we know same.
Same. This is very important. If I say, guys, let me know if you can see these. Can you all see this?
Yeah.
You can see this? Okay. How did you find out they can see this?
You have to learn.
How do I know whether they saw this or not? Give me a minute. Guys, can you all see? No.
Yes, doctor.
How do we make it large?
Let's just press on this thing, token. Yeah, the one box. Oh, that's not one. Another box.
Huh?
Another side, the 2 box. Yeah.
Okay.
That's the box.
Let me see. Just let me know if they can't see this. Let's say if we have
They can see.
online teaching, I hate you.
Yes, we can see that.
You can see.
Yeah.
Okay, let's say this is a compound, any compound. I have a carbon in the center, I have A, B, C, D. Okay, so in stereoisomers, right, any two molecules would be called as stereoisomers if they have what? Same molecular formula, same connectivity. So for example, if I say these two are my isomers, this and this, you can say this. These two are my isomers, right? Let's say this is iodine, fluorine, chlorine, bromine. Iodine, fluorine, chlorine, bromine, right? So these two compounds can be isomers. How? Can be stereoisomers. How? Right? If you see here, both of them will have chlorine. For example, let's say chlorine, fluorine, bromine, iodine, right? Both of them will have the same number of same atoms. Both of them have the same connectivity, right? But I can call these two as stereoisomers. Why? Because they behave differently in 3D space. The 3D orientation is different. For example, if this has black one at the top, let's say black is an iodine. If this has black one at the top, I can keep the black one on the right-hand side. I can do it like this. Did I change the connectivity? Did I remove any bonds over here? I didn't. They have the same molecular formula, same connectivity. It's just that here the iodine is at the top, here the iodine is pointing towards the right-hand side. Do you understand what I'm trying to say?
Yes.
So these two will be called as the stereoisomers. So stereoisomers are those which have same molecular formula, same connectivity, same number of atoms, same bonds, same functional groups, but they only differ, same physical properties, same chemical properties, but they only differ in one thing: how they are arranged in their 3D thing, right? In their 3D arrangement. In the spatial arrangement, they differ in that. And you will see that in this chapter, these stereoisomers can have different biological properties. When I say biological properties, what does that mean? That means the way they react with the biological molecules, with our enzymes, with the proteins, with amino acids. That is altogether different. So everything same except the biological properties and the spatial arrangement is different. Now, these stereoisomers are of two types. We have enantiomers and the diastereomers. As I said, that the whole chapter is, we'll talk about enantiomers in detail, right? Diastereomers is basically the next chapter. We'll talk about the carbohydrates, but yes, we'll introduce the concept over here. So now what are enantiomers? Enantiomers, are they stereoisomers or constitutional isomers? That's my question first. They're stereoisomers, right? But how do you define the enantiomers? We define the enantiomers when you have, okay, when you have, for example, two compounds. Let's say I keep the black one like this so that you know. I have two molecules which are stereoisomers. Okay, I keep it here and then keep a mirror here. When I keep the mirror here, what do you see? You see the mirror image of it, of this?
Yeah.
Guys, can you see the mirror image?
Yes.
Online. Do you think if I keep a mirror in the center, do you think these two are mirror images of each other? They are.
Yeah.
Right? If you see here, the yellow and the red one is pointed towards this side, and here the yellow and the red one is pointed towards this side, except because they are mirror images like this, like my hands. Right?
Yes.
What are enantiomers? Enantiomers are those stereoisomers where when you try to superimpose them like this. Can you see the superimposition, guys? The online ladies. Can you see the superimposition? Yeah. So when you try to superimpose them like this, so can I superimpose them? Boys, can you see this? If I'm trying to, these are two mirror images. If I'm trying to superimpose them like this, are they superimposable?
No.
Some of them are. Some atoms are.
Yeah.
Black and black is superimposable. Yellow and yellow is superimposable. What about these two?
No, it's not.
It is not. So for an enantiomer, enantiomers are those stereoisomers where the two molecules which are mirror images. The first criteria is that there should be the mirror images. So enantiomers are the mirror images of each other, but they are what? Non-superimposable. Can we superimpose them? No. For example, if you now look at this point very clearly. If I try to rotate this, look at the colors. Forget about atoms over here. I have yellow and red on this side, yellow and red on this side. Okay. I say that okay, they're not superimposing like this. Let me rotate them. It's a 3D model, right? Let me rotate them. I'm going to take a 180-degree rotation like this.
No.
Are they superimposing?
No.
See, purple, purple, black, black, blue, blue, but still you have these two. Don't even rotate 180. Turn them whatever way you want to turn them. Can they? Now purple, purple, even turn them whatever you want to do. Whatever rotation you do, whatever you do in this world, the two enantiomers will never superimpose with each other. Can you all see at the back? So no matter what, if I turn this, I rotate this, they will never. Superimposition means what? Atom on the atom, bond on the bond, everything should be so. Like every color, like this is red and red, black and black should be, every color should be superimposed. Every bond should be every atom should be superimposed. Then we can call it, then we have a different word called an chirality. We'll discuss that in a while. So how can we define an enantiomer? We can define an enantiomer by saying that enantiomer are the stereoisomers whose molecules are what? Non-superimposable mirror images of each other. Can I say that? So this was the stereoisomers. So this is he has taken an example of 2-butanol. The way I did it, I showed you practically. He did it on paper. He took 2-butanol like this. When one is ethyl, one is ethyl, one is hydrogen, one is alcohol. And then he tried to rotate it. You see here, he tried to rotate it in this one, the way I rotated it. But he's trying to tell you that no matter what you do, they will not be superimposed. But before I start discussing a few other things, do you know what is the formula of, what is the meaning of this wedge and broken wedge and solid wedge? The solid one is going out of the paper, the broken wedge. Do you find this? Have you ever done this in chemistry? No? It's basically, there are two different ways of writing a particular molecule. On paper, right? We write it, like this, for example, 2-butanol on paper. How will you write it? 2-butanol, OH here, right? And then you have CH3, CH3, H, H, right? Is this a 3D arrangement? No, write it on a paper like this. But if it's the same molecule, 2-butanol, I want to show it how it looks in the way I showed you here. How it looks in space. I use the dot wedge convention. I'm sure that you know all this in chemistry, but that's okay. What's the dot wedge convention? In dot wedge convention, the same 2D, we take it as 3D, but how do we show that 3D on paper? This is 3D on paper. This is not, I brought it here, like, the molecules.
Yeah.
But this is 3D on the paper. How do you show 3D on the paper? It's simply that you take, this is the OH, this is CH3, for example. This solid wedge, this one, solid wedge always tells you that the group or atom is facing towards you, like this. It's coming out of the paper, like this. And this broken wedge, this one, it tells you that it's behind the paper. I'll show you on 3D here. I'll show you what I mean actually. So let's say this is 2-butanol. In this, what do I have in the front? I have ethyl in the front and hydrogen at the back, right? So we have 3, this, this, and this. They're on the paper, like this. Right? Online girls, can you see? These 3 are on the paper. The red one is coming out, isn't it?
Yeah.
So red one is my, which group? Ethyl group. This is the plane of the paper. These 3 are on the plane of paper. Look at this, these 3. The red one is ethyl, which is coming out of the paper. And the red one is the ethyl, which is coming out of the paper. And the yellow one is the hydrogen, which is behind the paper. Like this is the correct way of showing. So these 3 are on the plane of paper. I hope this is. Guys, these 3, I'm not very sure whether you all can see this or not. So the black, purple, and blue is on the plane of the paper like this. If you see here, I'm not very sure whether you can see this or not. Guys?
Yes, we can.
You can, right? So the red one is coming out. So red one is an ethyl group and the yellow one is at the back, right? So that one is the hydrogen, right? This is called the dot wedge convention. This is the same thing, non-superimposable. So what is the reason behind the non-superimposability in the enantiomers? What is the reason behind it? Why don't they superimpose with each other? If I showed you these 2, why don't they superimpose on each other? Why don't this and this superimpose on each other? What is the basic reason for enantiomerism?
Carbon.
What kind of carbon? What is chiral carbon? Very good. Very good. Chirality. The reason behind enantiomerism is, right, why they are the compound I showed you here, why they cannot superimpose each other, because it is a chiral compound. What is a chiral compound? A chiral compound is that compound which we have, for example, if we have carbon here, carbon has 1, 2, 3, 4 different groups attached to it. Isn't this molecule a chiral? Yes or no?
Yes.
4 different groups are attached. 2-butanol, one is ethyl, one is methyl, one is hydrogen, right? One is alcohol. So if you have 4 different groups attached to the carbon, this carbon will be called as a chiral carbon. Or we use another term nowadays, we use the term stereogenic carbon. There is a difference between a stereogenic and a chiral carbon. I will not go into that chemistry details. Okay, all chiral carbons are stereocenters, but all stereocenters are not chiral. But I will not go into those. You don't even need to know all that. Then you'll be confused. So remember that in older terms, we used to say chiral carbon. So this purple thing which you see here is a chiral carbon. This is a carbon which is attached to 4 different balls over here, isn't it? 4 different groups over here. So the moment you see 4 different groups, right? You said, oh, this molecule is chiral because it has a chiral carbon or stereogenic center or stereogenic carbon over here. This is the major reason for enantiomerism because 4 different groups are attached to it, right? So a carbon with the 4 different groups bonded to it is called as a stereocenter, as it's shown over here. See, it has chlorine, iodine, hydrogen, bromine. So is it a chiral carbon? Yes, this is a chiral carbon. Is this a chiral molecule? Yes or no? Is this a chiral molecule? Yes. Then we move on to the next topic called as, okay, how can you say that this is chiral? You have to remember 3 things. A molecule to behave as a chiral should have at least 3 things. 1, it should have what? A chiral carbon which has what? 4 different groups attached to it. Point number 1. Point number 2, there should be non-superimposable mirror images of each other. And number 3, they should have no symmetry. They should be asymmetrical. What is asymmetrical? Asymmetrical is, for example, if you divide the body, mid-sagittal cut, anatomy, your left-hand side is equal to right-hand side, isn't it?
Yeah.
Transverse cut. Is your superior equal to the inferior one?
No.
So it's asymmetrical like this. Similarly, if I take this, okay, and if I divide it in the middle, here, I go through the atoms. So do I have right-hand side equal to left-hand side? Of course not. But if I take another molecule like this, look at this. If I divide it in the middle, is it symmetrical or asymmetrical? Symmetrical, because if you see here, red and red will be same. So is this chiral? No, it's not. Is this chiral?
Yeah.
Yes. So 3 things should be satisfied. 1, as I said, it should have what? A stereocenter, a chiral center. Number 2, non-superimposable mirror images. And number 3, a molecule should be asymmetrical. These are the 3 criteria for a particular compound to behave as a chiral compound. Now, what is achirality? What is achiral? I'll remove these 2 groups now. I'll take these 2 now, the smaller ones. What is the difference between the bigger and the smaller one?
We have 2 molecules here are the same.
Okay, right. What is the difference between the 2? Here we have 2 molecules similar, right? 2 red balls are similar here, right? So can I say this is chiral?
No.
It doesn't satisfy the first definition.
Yeah.
It should have 4 different groups. So is this carbon a chiral carbon?
No.
Is this compound a chiral compound?
No.
So we call them achirality. Now let's test the chirality. Now let's test it. I said that chiral molecules will be what? Non-superimposable, which I showed you earlier, right?
Yeah.
But let's see, are they superimposable? Achiral, should they be non-superimposable or imposable? Like they can be superimposed. The achiral. They should be they should superimpose on each other.
Yeah.
Yes or no?
Yeah.
Okay. Let me keep it like this. Okay. On the right-hand side, this on the left-hand side, this on the top, right? If I try to superimpose them, I hope, can I superimpose them? Yes?
Yes.
Yes?
No.
Yellow on yellow, red on red. Look at the back.
No.
Can they superimpose?
No.
They're not superimposing. So are they chiral?
No, because we have to do the 3 things first.
Yeah, very good. You're right. So can I superimpose them?
No, we cannot. No.
Absolutely. If you flip it, if you remember in this one, what I did, I flipped in all the positions. It could not be superimposed, but look at the magic now. I will just take a 180-degree turn like this. I just took the 180-degree turn and look at this. Can they superimpose now?
Yes.
Yes.
I did a magic, right?
Yes.
Purple on purple, yellow on yellow, red on red. And so are they chiral now or achiral? Achiral. Because look at this. They can beautifully superimpose all the atoms. Look at this. All the atoms. All the sites. Do you all understand what I'm trying to say?
Yes.
So these will be, so what is the condition for asymmetrical? Point number one, they have no stereo center. Point number two, can they superimpose? Can the mirror images superimpose? No, they cannot. Point number three, do they have plane of symmetry? They should have, right? I showed you already. If I divide it in the middle like this, a mid-sagittal cut, and red on either side, so they will be mirroring. So the left-hand side is equal to the right-hand side. So they show symmetry. This is the difference between chiral and the achiral.
Doctor, so achiral shows symmetry?
Yes, achiral shows. I showed you. Did you see the compound? I can show you on the board as well.
Yes.
Just on that, look at this. If I divide this molecule in the middle, what do I have? I have at least methyl and methyl are similar, isn't it? So does it show plane of symmetry? Yes or no? They show plane of symmetry because it's what? It is achiral. Let's try to see the other one, the chiral one. If I divide this in the middle, is there any way that left-hand side is equal to right-hand side? No. I have bromine on this side and I have chlorine on this side. So they lack symmetry. So we call them as asymmetrical, or we call them as chiral compounds with the chiral center in that. I'm going to switch off the camera, ladies, now. That was all about the models. I have two now. Now you all need to pay attention. And so to summarize, okay, now I'm going to show something, which you all need to know, and I'll tell you why that's important. So how to summarize, yes, please.
I have a question, please.
Please go ahead.
Which one has to have a centerpiece, the achiral or the chiral?
Which one has, what do you mean the centerpiece? Which one has chiral carbon, you mean?
Yeah.
Okay, I'll show you the next one. Can you tell me which among these molecules is chiral? You all will keep quiet. Can you all tell me which one is chiral?
C is chiral.
A is chiral. Why?
C.
C is chiral.
No, C is chiral.
Only C is chiral. I have bromine here, chlorine
And
here.
so is A.
So is this a chiral carbon? Yes, I will mark it with the asterisk. We mark stereocenters or chiral carbon as an asterisk. What about the B1? Who was that who asked me the question?
Toluene.
Sorry?
Toluene.
Okay, Tuli, what about the B1? Is B1
No, B isn't chiral.
is or it isn't?
It isn't.
Why?
Because there are two A hydrogens. They also have 4 different groups.
Very good, very good. It does not have 4 different groups attached to it. So this is not a chiral compound. So we do have we have a stereogenic center here? No.
No.
Center means when, for example, in this case, this carbon has 4 different groups attached to it. So this will be a stereogenic center. So you can use the word chiral carbon or you can use the word stereogenic carbon. It means the same thing.
Okay, thank you so much.
Okay, now who tell me from the class? What about A and this one? A is A chiral?
Yes.
4 different groups. Who will answer this? Munira.
Yes, miss.
Is this chiral?
Uh,
This one?
yes.
Why do you say that? Because
We have different.
4 different groups. So can I say this carbon is a chiral carbon?
Yeah.
I can see. So we mark chiral carbon with the stereo because that is your next job now, to mark the stereo centers.
With a star.
You mark them with a star. Okay? That was all about enantiomers. So what did we learn? We learned that if I say that these two are enantiomers, because they are chiral, right? That they have 4 different groups attached to it, then both of them have same molecular formula, same connectivity, right? Look at this, same connectivity. Same physical properties, same chemical properties, but different biological properties. And how will I distinguish these two? If this is 2-butanol, 2-butanol, how will I know that these are 2 different compounds now, right? They're not one compound. There's 2 different compounds, 2 enantiomers, 2-butanol, 2-butanol. How will I actually differentiate between the 2-butanol and 2-butanol? There should be something which would tell us that, okay, this is this, because the IUPAC naming is similar. In enantiomers, the IUPAC name is similar in both the cases. This is also 2-butanol, this is also 2-butanol, right?
Yes.
So how will you differentiate between the 2 enantiomers? Then we have the Kahn and Gold pre-log system. They have given us something called as RNS configuration. What is RNS configuration? We use the prefix R and S. For example, we can have R-butanol, which will give this name to the original molecule. And then I have a mirror image. I might call that as a S-butanol. Can I differentiate between these two? You can. Because you will see that in this chapter, we'll talk about drugs. You'll see that how there are some drugs which are, if there are enantiomer, they're active. The S1 is totally inactive. Ibuprofen. We all eat ibuprofen when we all have fever. Anti-inflammatory drug, high fever. Doctor gives us ibuprofen. Do you know ibuprofen is chiral? Point number 1. Do you know that ibuprofen has 2 pair of enantiomers? The R is inactive. It doesn't do anything in my body if I eat R. But S is active. So that means you have to consider R and S as 2 enantiomers are what? 2 different molecules. So that is why they should be given different names. This is the 2 enantiomer ibuprofen. We'll come back to drugs at the end once again. Okay. But right now, I want there will be definitely 2 questions in the midterm about, and this is something which I found, students always struggle with this. So I want all of you to pay attention. How to assign R and S configuration. This is something mathematical. Take out your books, take out your pens, everyone. Pen, books, rough notebooks, because we need to show to be how to assign R and S configuration. Ladies, boys, which are online connected, please take out your books, pencils. And in the midterm, for sure, there will be a couple of questions or 1 question, or depends, or 3 questions on how to assign RS configuration. That's for sure it will be there. And now if you don't learn it, trust me, it will be very difficult at the time of midterm. So if you have questions, please let me know. The first step to assign the RNS configuration is, okay, we arrange the groups in the order of priority. What does that mean? That means we give priority to what? To the atomic number. For example, if I have carbon, I have iodine, I have bromine, I have chlorine, and I have hydrogen attached to it. Tell me, which one will be given the priority? Girls online, you can also respond. Which one should be called number 1?
Iodine.
Iodine will be number 1. Which one will be number 2?
Bromine.
Bromine will be number 2.
Then, chlorine.
Chlorine will be number. Please do not write, guys. As I said that I'm teaching on the board, I cannot check your chat. You need to switch on your mics and answer, please.
And 4 for
You need to switch on your mics and answer. 4. That is how to solve your question. The first thing what you do is you give priority to the groups based on the atomic number. Once you do so, okay, then you see, okay, let me see. Okay, let's forget it. I'll tell you that in the next step. Now the question is, if you have groups like this, for example, where you have a double bond, everyone please pay attention. It's the most difficult part students face with this. They always struggle with RNS. And definitely, last time also, before that also, we always have a question and we give question. Definitely there will be a question in the midterm and the finals for the RS configuration. So please pay attention. Now, if you have double bond like this, what do you do? So we consider this double bond. Whenever you see this group and you have to assign a priority, what do? You consider, oh, I'm sorry. You consider the double bond as if it is what? 2. As if you have 2 oxygens here. So I will say this will be considered as if I have what? 2 oxygens here. And then I have OH. O. Atomic number for oxygen is 888. Atomic number, right? Correct?
Yes.
What about this? Same thing. We'll consider double bond as if you have what? O and N. Atomic number for oxygen is
887.
If you have this group and if you have this group, which one will give the priority? This group or this group? Why?
The first.
Yes, you're correct. Don't be afraid. Why? Because
It's 888 instead of 887.
you'll understand?
Yeah. Higher.
Absolutely. Right? Similarly, if you have this group, which has oxygen is what? 8.
8.
Oxygen is 7. So priority will be given to which? Which one? This one.
8.
Isn't it?
Yes.
That is how the first thing what you do when you see a molecule in the exams, you need to give them priority. Based on what? Atomic number. Let's do this now. I'll show one. I'll solve one for you. The next one you all need to solve. Okay. So let's, how now we have to choose which one to give priority. The first thing what I do is I always try to open them up. This is what? H, OH. What will it be, Yara? Hydrogen is what?
Let's have only one.
1,
One.
1. Oxygen is
8.
8. Let's see the other group. You have to choose between the two. Which one has higher priority? C, H, CH2, OH. So I have hydrogen,
It's one.
I have carbon. This is 1. This is 6. This is 1. 1, 1, 6. Which one should I give priority?
First one.
Muhammad. Which one should I give priority? So this will be prioritized. Are you able to understand?
Yes.
Stop me if you don't understand. Ladies online, boys online. Yes, dear.
With the carbon one, do you not count the H?
No. We see the immediate one. This carbon is connected to this hydrogen, and this carbon. We're not worried about what is there. But yes, we will count the other ones if this would have been carbon over here. And this would have been carbon over here. Then all 3 were carbon. Then I will move to the next one.
What, Doctor?
So if they're the same, then you just count, you move to the next one. But if they're
Exactly.
different, you just choose the first
Absolutely.
one.
Why? So the problem was here, I don't have to go to the next one because this was hydrogen and this was hydrogen, right?
Yeah.
But if it would have been carbon, then I would go to the next one. Got it?
Yeah.
Munira, let's do this one now. CH2, right?
Yes.
CH2OH. So what is this? 1, 6, 1. What is this? What will be this?
1, 6.
Absolutely. And by looking at this, you can simply say that I'm just trying to show you the longest way so that you don't make any mistake. Carbon is connected to what? Hydrogen,
Yeah.
nitrogen, and hydrogen. So this will be
1,
1,
7.
7. So which one should we give for this or this one? This
Yeah,
or this
one.
one?
Right one. Yeah.
This. Are you able to understand?
Yes.
Clear? What about ladies online, boys online? Please switch on your mics.
Doctor,
Clear.
Professor,
Yes.
can you please repeat how you did the second one?
This one, you mean B?
Yeah, CH2, CH2OH.
Okay, what I did is like, this is 2 hydrogens here, right? I simply opened the structure. I put 1 hydrogen here, 1 hydrogen here, correct? Then we have C over here. C, then I wrote the whole group, CH2OH. Then you have hydrogen with the atomic number 1, another hydrogen with the atomic number 1, C with the atomic number 6. So I wrote 1, 1, 6, right? Now let's find out in the second one what happened. In the second one, I opened the structure. So I have 1 hydrogen here. If I don't want to write it this way, I have 1 hydrogen here. And then what do I have? NH2, amino group. So tell me, H at N. What is the atomic number for nitrogen?
5.
7.
7. You will anyways get the periodic table. No need to worry about the atomic numbers. We'll give you the periodic table, right? So this is 117. Which one should be given priority? The first or the second one?
The second one.
Because what do we have? We have nitrogen over here, isn't it? Yes, dear.
Why we didn't count the H with the OH? We just count the O.
You have to see what all is connected with the carbon. You have to see what all is connected with the carbon. Which one? In this one or this one?
Oh.
This one?
Yeah, they're both the same.
Yes, I need to see the immediate, and if you see that with this carbon, I have only hydrogen at.
So we see only for the.
We see the first one.
Right.
You will give. I will give you next time. The questions where you will see that there will be 2 C's here. Then we move to the next one. You know what I'm trying to say?
Yes.
Then you move to the next one. You go to the next one. It's like, I have to take students for scholarship to US.
Yeah.
They told me you can bring anybody who has 100% the GPA.
Yeah.
I found that I have Mohammed and Yara with 100% GPA. How do I choose these 2? The first criteria failed. Both of them have 100%. What do I do now? Then they told me go to the next step. Check their PHSF because they're going to study medicine. PHSF is important. So I check their medicine marks. So I go to the next one. If these 2 are similar. So both of you have 100 marks. I check your PHSF now. Yara had 100% in PHSF and Mohammed had 90%. Which one should I choose?
Yeah.
Okay. If PHF is also similar, if the next item is also similar,
We need to jump.
you go to they said, okay, then check the biochemistry marks. The next important thing is biochemistry. So I will move on to the next atom till I find the difference.
Okay.
What if the molecule on the left, the top hydrogen was one on the left?
As I said, if it was hydrogen here, for example, right? If this was nitrogen, I would still choose this. Because you see carbon and nitrogen has higher atomic number. Got it? That's very important, right? The first thing which is attached to the carbon is very important. If they are similar, we'll do some more examples, right? Then you will see that if the carbon is similar, then how do we go to the next one? Okay? So you can solve these 2 similarly like this. Okay, now in the examination, we give you molecules like this. And we tell you, okay, tell me, is this R or is this S? Which among the following have R configuration? We give you 4 molecules. Which among the following have S configuration? How do you attack this problem? Now, wedge dot convention. Remember, the ethyl group is towards the front. Remember? The broken wedge. This broken wedge. This is towards the back. This one is towards the front, right? We know that. Because this is very important in this. Now let's try to see, let's try to give priority. Okay. So what's your name? Sorry? Abdul Rahman. Yes, dear. Tell me. I have 4 groups. Tell me. Let's start with the down one. Number 4. Which will be number 4 for me? Abdul Rahman. OH, CH3, CH2, CH3H.
Starting from now, right?
The least one.
Yes,
The least
yes.
atomic number.
Yes.
Very good. So the first thing what I do is always, that's how I solve it. I really have to say number 1 first, then number 2. I always give what? Number 4 first. Because you know, it omits that. So 4, if I see oxygen has atomic number what? 8. Carbon has 6. Carbon has 6. Hydrogen has 1. So for me, it is what? Number 4. Correct?
Yeah.
Okay. I'm erasing this because I don't want any confusion here. Now I wanna, which is the highest priority? Which one is the highest priority? Is it carbon, oxygen? Look at which atom. Is it carbon, oxygen, or carbon?
Oxygen.
Oxygen.
Atomic number 8. So this will be number 1. I have a tie now. The way I was telling you, the Yara and Muhammad. Both of them have same marks, same GP, 100%.
We have to jump. See the second one.
Go to the second one. In the second one, I have here, I'm going to erase this. I hope it's clear with the online people. In the second, I'm going to open this. Okay. I have 3 hydrogens, right? What if I don't want to write this hydrogen? I have hydrogen, hydrogen, and hydrogen. So what will it be? Hydrogen has 1, 1, 1. Correct? Let's see the other one. This is CH2, CH3. I will open it. I said the opening will help you always. So if I open it, this will be H. Another H here. If I don't want to write this, then I have C over here, right? The C over here. So this will become what? 1,
6.
6. Should I give priority to this or to this? Right. Okay, I'm going to erase all this so that, as I said, that I want it to be clean so that we decide is it R or S. So what did we say? Which one was the next priority? Second one was CH2, CH3, right? So this was my number 2. This was my correct. Now pay attention. If you look at the lowest one is what? H. If this is at the back, this dash will tell you it's at the back. If it's at the back, forget about it, as if it doesn't exist. It's not there at all. This is the rules, which the way we have to assign RNS. If you're the least atom or least group is at the back, this broken wedge will tell you, right? It's at the back. Forget about it. Take the first 3. And if you go, I need to go 1, 2, and 3. If you move what? Clockwise, clockwise?
Yes.
The way your clock moves. Then this is your R configuration. It's clockwise. If it is anti-clockwise, then it is the S. Is it clear? Step 1, assign the priorities. Step 2, what do? You see the lowest one, right? Which you have given the 4th priority, right? Least priority. Is this at the back or the front? If this is at the back, then forget about it, and it doesn't exist. Sorry? I will give you example. I will not leave this classroom unless I show that. Don't worry, I know that. That's very important. Right? So I give you one example where the broken wedge or the least one is at the back. And then see if it's clockwise and anti-clockwise. If it's clockwise, it is R. If it's anti-clockwise, it is S configuration. Students online, did you all understand?
Yes,
Yeah.
doctor.
Very, very, as I said, that's very important. Shall I move to the next one? Okay, let me see who can solve the next one. I'm giving this assignment to everybody online. Okay, and I will ask a person to share the screen. Okay, you simply need to, or you can share your screen, your notebook or your screen. Solve it on your screen, solve it on the Word document or your iPads, and you can also solve the second one. Tell me the B one. This is an amino acid. R or S? You did it?
No.
Yes.
Oh, you want me to do it?
Yes. And I would see you. I'm coming to everybody.
Oh, okay.
Tell me which one has first priority, second, third, and fourth. Online girls and boys.
Nitrogen is 7.
Sorry?
Nitrogen is 7.
Nitrogen is 7, yes. I'll ask a person to share the screen. Done, Mohammed? You have a very big notebook. It will be S. Okay. No. Think once again. Why did you have 1 for hydrogen? 4 for hydrogen, the least one. The lowest one will get 4. What is R of it? You know what I'm saying either? What about you? Yeah. Number 1. Okay, number 2. Okay. Okay. I'll give you the answer. Very good. Yes. Uh-huh. Uh-huh. Okay. Anybody else? Is there anyone who solved it online?
I did, doctor.
I did, doctor.
Who's that?
Yes, doctor.
Give me a minute. Who wants to share the screen?
Could I share the screen, doctor?
Yes, give me a minute.
Okay.
Partner to share screen. Yes, you can share the screen.
I cannot until now.
We cannot see it.
Yeah, I couldn't.
Doctor, I think there's a pen on the side where you can write. There's a pen enabled.
To share the screen.
Miss, maybe you have to stop sharing. Yes.
Okay, I need to stop sharing. Okay. I've stopped sharing.
Okay, I can.
Yeah.
Okay, just a second.
No, we cannot see anything, Muhammad.
We can see now.
Now we
Did
can
you see it now?
Yes.
Yeah. So the lowest priority is the hydrogen.
The least one is hydrogen. Very good.
Yeah. So it will be 4.
Very good.
And for the first or the higher priority, it will be the nitrogen. So it will be 1, the first, and then the second will be the carbon.
Very good.
And then we will go to the hydrogen here, which is the third.
Very
It
good.
will be clockwise, so it will be at the end R alanine.
Are absolutely correct. Thank you, Muhammad. Thank you. Wonderful. Very good. Super. Thank you.
Okay, thank you.
Wonderful. Did you all understand? I'm going to solve it. Yes, I will solve it. Don't worry. I'm going to solve it. Okay, which one was that? This one? Okay, I'm going to solve it. I'll tell you what mistake you did. Did you find a mistake? I didn't come to you all. Did anyone solve it from there?
Oh, I saw.
Did you solve it? Did you do the way he said? One. So this is out. Yes. No. No. Okay, let me solve it for you so that it becomes clear to everyone. Okay. I always give the least priority first, right?
Yeah.
So which one will be? This is carbon, this is carbon, this is nitrogen, this is hydrogen. So which one has least atomic number? So this will be number 4. So this is carbon 6, this is 6, this is 7. So which will get priority? Nitrogen, right? So this will be number 1. I have a tie between these. This is also carbon, this is also carbon. What will I do? What will I do? Remember the double or COH? Whenever you have this carboxylate group, you're going to break it. So that means you're going to write it how? C double bond O OH. This group, isn't it? So this will become O is a double bond. So remember I told you to take it as if it's two oxygens, right? So this will be what? 8, 8, and 8, correct? Okay. So what do we do here? This is 8, 8, and 8. What about this? If I open this. This is 1, 1, 1. This is higher and this one is higher. This one. This goes by number 2. This goes by hydrogen is at the lowest one. What do? I move. It is. Isn't it? We'll do some more examples. It will be more clear. Ladies, if someone did not understand who is online, you can come to me and meet me in the university. I can teach you in my office. Don't worry. Okay, you can come to my office and I'll teach you here. If you feel like online you did not understand. Okay, who will do this one? I want everyone to solve this, and I'll ask you all to share the screen. Ladies, everyone.
Is it the same example?
Is this the same one?
Yeah,
it's the same. Okay, good. So let's do the second one. Okay. Okay, this one I have to solve because here the least one is not at the back. I'll solve the second one. Guys, wait, I'll solve the second one. Okay. Once again, least one is?
Hydrogen.
Here I have what? Carbon. See, they have it in the wrong way. We don't write it this way. But the bond is, it's basically like this, right? CH2, then CH3, right? It's carbon here, right? You know that. Okay. So I have carbon here, I have oxygen here, I have carbon here. So carbon here is 6, this will be 6, this will be 8. So which one will give highest priority? Oxygen, right? So this will be my
8.
This will be my 1. So this is my 1. Now I have a tie between this is C, this is also C. What do I do?
Oh, that one's better.
Next one.
Yeah.
Next one, this has what?
1.
Hydrogen. If I don't write it this way, this is also hydrogen. And then it has C here, right? It has C here. So it becomes what?
116.
116. And this, if I don't want to write this one, it becomes what? Hydrogen, hydrogen, and hydrogen. This becomes 1, 1, 1. Which one should get priority?
The one on the left.
The one on the left. So I'm going to erase all. As I said that I don't want it to be dirty. So which one will get? This one, right? This one, 116. Okay. So this will be my number 2. This will be my number 3. This question has a problem. I told you if the lowest one is at the back, like a broken wedge, then you will forget about it. But Is that happening?
No.
Here, the H does not have the broken wedge. Look at this. It is like a normal one. It's not a broken wedge. So what do we do in this? Anyone?
It will be F.
What will we do with this?
Nice touch.
Okay. Anyone?
1, 2, 3, 4.
Okay. We will still omit this 4. Okay. And I will go like this. 1, 2, 3. What is this?
R.
R. I will not write this as R.
S.
If your hydrogen is not at the back, the way it is like this, whatever you get, if you get S, do the opposite. If you get R, do the opposite. So this is my S configuration. You might think that this is R, right?
Yes.
Because it is clockwise. But I wrote it as S because my hydrogen or the lowest one was not from the back. When you get questions like this, right, where your lowest group is not at the back, whatever you get, if you get R, write the opposite S. If you get S, write the R.
Okay.
Clear to everybody, guys? Online.
Doctor, I have a
girls?
question.
Yes, yeah, please go ahead.
Why can't you forget about it if it's in the back?
I'm sorry.
Why can't you forget about the hydrogen, even if it's in the back?
I forgot about it. That's why I'm going 1, 2, 3. I told you that even if it's not at the back, I forgot the 4th one. That's why I wrote 1, 2, 3. If you see here, I wrote here, I forgot about it. There's a crossover here. I forgot about it. I wrote 1, 2, 3. So it was clockwise. So it should have been ideally R. But then I told you have to remember one more rule. If your lowest one is not like a broken wedge like this over here, then whatever you get, you have to write opposite of it. So that is the S1. This you have to
Thank
remember.
you.
You have to make sure that you have to check is your hydrogen, is your lowest one at the back or if it's not at the back. If it's at the back, you will not touch it. You will, write it the way it is. But if it's not at the back, then you will do the opposite.
So if the lowest one's at the back, you do the opposite.
If it's not at the back. If it's
Okay.
not at the back, right? In this example, we don't have hydrogen at the back. We have methyl at the back. So that's why I did the opposite. It was R, I chose S. Okay, who will do the next one? This is like an easiest of all.
Doctor, I have a question on the one before.
I have a
Okay, yes, please go ahead. Meanwhile, everybody will solve this. I will ask you to share the screen and you also solve this, everybody. Yes, dear, please ask your question.
I didn't understand why how we chose between 2 and 3.
Choose between 2 and 3. Oh, okay. Okay, let me check write this one first, then I'll show her. How is it?
Doctor,
Yes, please write it down, everyone.
can you
Yes.
please explain how you assign the numbers?
I have been showing that from past so many slides. You were not connected with us?
No, I understood, but I couldn't understand between 2 and 3 in the last example.
No problem.
I have the same question too.
Okay, don't worry. I'll explain you once again. Don't worry. Meanwhile, you all can solve it and tell me. And you can solve the next one also. There's one more example after this. Can you all write the compound? Then you can write this. Solve this one first. Okay, meanwhile, I'll explain her this one. Okay, guys, let's do this once again. I said that the lowest one will be 4. You understood that part, right, guys?
Right.
Yes.
Don't you guys now. Give me a minute. You all can discuss, no problem if you want to. Oh my God. Wait a minute, guys. You will not find these questions here. I added them.
So what is that?
Let me show her this one. Give me 1 minute. Okay. Oh, what's wrong with it now? I clicked it back. Oh my God. Don't tell me. Everything is like, pen is so very important in this class. Give me a minute, ladies. My pen is not working somehow. Let me use this one. Okay. Okay, good. So we said this is number 4. Okay. And we said this is number 1 because we have oxygen over here. Now we have a doubt between this group and this group, right?
Yes.
Both of them have, because I know that the compound is supposed to write it like this way actually. It's something like, if you see here, this is like CH2, and then you have C. What's wrong? This one is CH2, and then you have CH3. So now tell me, and this side I have CH3. So we have C and C here. Both of them are like 6 and 6. This is also 6, this is 6, also 6, right? So I move to the next atom. Okay. So the next atom here is hydrogen, right? So if I open this, this will be what? Hydrogen is here, hydrogen is here. So this will be 1, 1, and this carbon will be 6. So this is 1, 1, and 6. Did you all understand? I don't know who asked me the question. So this will be 1, 1, and 6 because this hydrogen is 1, another hydrogen is 1, and this carbon is 6. So 1, 1, 6. And this one, if you see on the other hand, we have, let me erase it. On this side, you have carbon 3. So you have 1, 1, and 1. So tell me, which one is higher, 1, 1, 1 or 1, 1, 6?
116.
Right? So that is why I give number 2 priority to this one, and number 3 I gave to this one. The only thing you have to remember is, guys, when you have atoms with the same atomic number, what do? You move on to the next atom. Tell me, is there anyone who solved the next one? Yes, yeah, I'm coming to you.
Yes. Yes, I did.
Okay, you did? Okay, give me a minute.
Yes, teacher.
This was a
This
question?
one.
Okay. Okay. 1, 2, 3. Wonderful. Wonderful. Did you check? You missed on something. It's correct. You missed on something. I did it. The lowest one is not at the back. This will be because if you see the hydrogen, the lowest one, hydrogen doesn't have a broken wedge.
Yeah. So you count that.
Yeah, and as I said that, you still omit it, but the only thing you remember is that if it's R, you will write it as an S.
Oh, right. Right.
Got it?
Yeah, I'm not sure.
This is 1. How come this is 1? No. This is 17 and the carbon is 6.
Carbon is 6. Okay.
Very good. Mira, this is number 1. Oh, finish it first. Mohammed.
Carbon is 6.
RS. Okay, someone online, guys. Let me choose one. Tashi, do you mind sharing your screen with me? Did you solve it, Tashi?
Miss, I can't share my screen, but I can tell you.
Okay, tell me, very good. Please go ahead. Is it R or S?
I was just solving it, but I can tell you the priority. H over here would be 4, number 4.
Okay, okay, give me a minute. My pen is giving me a trouble. Okay, so Tashil said that this will be number 4. I'll solve it for you. Okay, then what will be number 1, Tashil?
Chlorine.
Wonderful. Number 2.
And then number 2 would be oxygen,
Very good. Number 3 will be,
the carbon of CH3.
okay. So what do? Do we have hydrogen at the back? Is it R or S?
It's S.
Yes, very good. How do you say that it's S? You're right, absolutely right.
Because hydrogen over here, it's the least prioritized, but it's not at the back.
Okay.
So even though we got clockwise, we're gonna take the opposite. So it's gonna be S.
So it was basically like this, R, but since I looked at the what? The least one which had a priority 4, right? It was not at the back, so it's going to be S. Wonderful. Thank you, Tashir. Awesome.
No problem.
Is it clear? You'll solve it now. The more you solve them, the more you get hold of them. Try to look, you got now, you solved, you got the, access to the book now, right? Yes. Textbook as well as the homework. I'm going to assign homework, maybe not this week after that. I'm going to assign homework. By that time, you need to finish buying the access code. So there you can solve many questions. Watch the video. Trust me, it's going to help you like that. It's going to help you in so many ways, not only in biochemistry, in chemistry as well. Okay. So we will not definitely give you compound like ibuprofen. Definitely not. This is the simplest of all, but we will not give you have exactly compound. So this is your R-ibuprofen, which is inactive. These two are pair of enantiomers. 2 different compounds. The R1 is of no use to us. The S1 is definitely an anti-inflammatory, and we eat it whenever we have high fever, right? Infection. So we're going to talk about drugs. The whole chapter is about drugs at the end. But first, we need to identify now the stereo centers. One more activity is coming up. I know that you all are tired, so am I. And I have next class to explain all this again for 1.5 hours. And I have been teaching from 8 in the morning. But I want you all to solve it. At least we can solve a couple of them. I know you all are tired. At least I want you to solve a couple of them. Okay. Now you know what is a stereo center, right? We saw in this particular model that this carbon can be a stereo center if it has what? 4 different groups attached to it. So I will call this carbon as a stereogenic carbon or a chiral carbon, right? So I will give you molecules now. Again, there will be, as I said, that in midterm 1, we always give 2 questions, maybe, for example, on to identify stereo centers, and 2 questions on to identify RNS configuration. So this will be again there for the midterm, so you all need to pay attention. If not difficult, let's solve it together, right? So we need to identify the chiral carbons in the molecules, or we need to find out the stereo centers, the carbon which is attached to 4 different groups. So if we know the stereo centers, right, we know that how many isomers it can have, because we know the formula, okay? If I have this model in my hand, how many chiral carbons it is having?
4.
Chiral carbon.
2.
Carbon, 1.
1.
This is your chiral carbon, right? Carbon attached to 4 different groups, right? So the question is, what you have to remember that if a compound has 1 chiral carbon, right, the formula goes that 1 stereo center, 2 raised to the power 1. What is it? Sorry, 2 raised to the power n. What is n? N is telling you the number of chiral carbons in that molecule, or number of stereo centers in that molecule. So in this compound, if I say that I have 1 chiral carbon, how many stereoisomers enantiomers can you expect? 2 raised to power 1. That means 2. Similarly, if you have 2 chiral carbons or 2 stereo centers, so 2 raised to the power 2. How many pair of enantiomers? 4. So your number of your number of stereo centers will tell you how many enantiomers can exist in that particular molecule. Now you'll get questions like this when you have to identify the stereo centers. And I'll tell you how to solve that. Everyone, please pay attention. Okay. If you get a question like this, please pay attention, everyone. Can this carbon be my chiral carbon?
No. To be in the center.
Why?
Because two are
It's connected to,
hydrogen. It has to be in the center and connect to
it doesn't have to be at the center. Just 4 different groups should be attached to it.
4 bonds. Hydrogen.
4 different groups.
Others.
It has,
Connected to 2H.
if I open it, if I don't want to write this, this is 1
No,
hydrogen,
it's
this is, can this be a chiral
No.
carbon? Of course not. There's 2 hydrogen, 2 groups are same, 2 atoms are same. This carbon cannot be my chiral carbon. Can this carbon be my chiral carbon?
No.
Of course not. Whenever you see double bond, just close your eyes. We want only sp3 hybridized. Okay, we want carbon to be what? Tetrahedral. So this is not my chiral carbon. This is not my chiral carbon. Can this be my chiral carbon?
No.
Why?
Because I have 3 hydrogen.
It has 1, 2, 3. We want something which are 4 different groups. So this is not my chiral carbon. Can this be my chiral carbon?
No.
2 hydrogens. This cannot be my chiral carbon. The first step to solve these questions is you remove or you omit all those groups which have 2 or more hydrogens. For example, because what is the criteria? We want 4 different groups. Now let's see this carbon. I want to erase this. Let's see now. Let's say, can this be my chiral carbon? Yes. On this side, I have what? If I want to bring this, if I want to opening the structures will definitely help you. Trust me. Putting in as many as hydrogens. You know, the hydrogens are hidden sometimes in the cyclic structures, right? So opening structures will help. So if I don't want to write this H here, so this H will be correct?
Yes.
So I have 1 different group here, 1 different group here. This side I have what? Different group, and this side I have different group. So this carbon is going to make chiral carbon.
Yes.
A stereogenic center which has what? It's a stereogenic carbon or a stereocenter because it has 4 different groups attached to it. So to identify stereocenters, do not forget to add an appropriate number of hydrogens to complete the tetravalence of each carbon. You might think the stereocenter will be. Remember this point. You will always remember this. Don't forget to put the hydrogens. Now let's discuss this. This is the last slide, trust me. Okay. Can this carbon be my stereogenic stereocenter? Why not?
Don't have.
It doesn't have anything. As I told you, open the structures. If I want to open the structure, this is my C, H, H, C, O, H, C, CH3, CH3, C, then H, H. Isn't it correct? Okay, and then you have what else? C. Okay, and then you have H, H. 1, 2, 3, 4, yeah. Because as I said that, open the structures. Because carbon, you know, anyhow carbon has to make 4 bonds. You have to make sure that carbon has to make 4 bonds.
There's missing H. O, this is 2OH.
Yeah, there's H over here. There's H over here. So can this carbon be a stereogenic carbon? No.
No.
Why not?
2 groups.
It has 1 hydrogen, 2 same groups. Khalas. Can this carbon be?
No.
Can this carbon be? No. Can this carbon be? Can this carbon be?
No.
No. Can this carbon be?
Yes.
Yes.
Stereogenic center, because what do I have? I have OH, I have H, and then I have this group, whatever it is. Why do I say that? It has 4 different groups. If you observe it this way, I said that this is my stereogenic carbon, right? This is OH. This is H over here, right? If I start moving from here, what do I get? I get C with HH and all that. But when I move from here, I meet a different person. C with all together or 2 methyl groups. So definitely this is a different group. This is a different group. So this is my stereogenic center. So this compound has 1 stereogenic center. Okay, and then how many enantiomers? 2 raised to power 1 is equivalent to 2. So it can have 1 pair of enantiomers. We'll stop over here. Any questions, ladies, boys?
Clear, doctor.
Clear? So you can solve the other examples. We'll discuss that. We'll discuss them in our next Wednesday's class. Okay. I hope today's class was all clear.